can inherit just from only one class. But with delegation, you can plug in multiple implementation of classes in your own class. And let's see how we can do that. So I'm going to create first an interface called A, and it's going to have a function called print. Then I'm going to create another interface called B, and it's going to have a function print too. Then I'm going to create a class. So I'm going to type here class, and it's going to be called first delegate, and it's going to implement the interface A here. And I'm going to press Ctrl O to override the function print here. And I'm going to create another class called second delegate, and it's going to implement the interface B. So I'm going to press Ctrl O to override the function print too. Now I'm going to create up here a class called up. So class up. Now let's say that I want here to inherit from the first delegate and from the second delegate, so and from the second delegate. And if I type here first delegate, I put parentheses, opening parenthesis, closing parenthesis. If I put curly braces, now I have an underline because I should mark this as open. So mark this as open, and also this as open, because I want to show you that. So now, if I want to inherit from the second class called from the second delegate, because let's say that I want to use the print2 function in my class for whatever reason, I can't, because I can only inherit from one class. So if I hover over here, over this underline, it says only one class may appear in a supertype list. So in other words, saying that we can only inherit from one class, and that is all. We cannot inherit from multiple classes. Now, with delegation, we can plug in multiple implementations in our own class. So what I can do here, I can say, hey, implement the interface A. So I'm going to inherit from the interface A, but you're going to say use for the interface A the implementation of the first delegate class. So this is what we're saying here. A and the keyword by first delegate, we're saying, hey, use for the interface A the implementation which is provided by the first delegate class, and that will work. Then I'm going to put a comma here, and I'm going to say use also for the class B. So I'm going to type for the interface B. So we're going to type B, and we're going to use the by keyword. So I'm going to type here by second delegate. So you're saying use for the interface B the second delegate implementation, and it's gonna use that, and it's gonna be happy with that. So you're gonna see that we get no error. And now I can override here both the print function and also the print2 function. So if I press Ctrl O, now I can override also the print2. And this is inherently very powerful, because we can plug in here as many implementations as you want in your class. So this is, and if you think about in contrast with the inheritance, this is very powerful, because here you can plug in as many implementations as you want, and this is very powerful. So this is how you can use delegation in Kotlin, and next we're going to see how you can use delegation with properties. So to use delegation properties, first I'm going to paste some code here. So I'm going to paste this code here, and what we're having here is a class format delegate, which is inheriting from the read and write property, and it's overriding the get value and the set value. So we are overriding the setter and the getter inside our class, and we provide our own implementation. So whenever you use the setter to set a value or the getter to get a value, we are overriding those functions, and we provide our own implementation. Next, I'm going to create here a class, but first I'm going to delete the code and the interfaces that we have here, because we don't need this code. So I'm going to delete this code, and I'm going to create another class, and this class is going to be called user. I'm going to put curly braces, and I'm going to define the properties inside the class. So I'm going to type here var first name. So what we are doing now is we're creating a property first. It's called first name, and now I'm going to use the by keyword. So I'm going to say by format delegate. So what we're saying now is we use the code which is inside the format delegate whenever you set the value or get the value of the first name. I'm going to put parentheses here. Next I'm gonna type another var, last name, and I'm gonna type here again by, and I'm gonna type format delegate. So format delegate, and we put parentheses. So now what is gonna happen is that whenever you set the first name property, or we get the first name property, is gonna use our implementation that we provided here. This is what we're gonna do, and the same it will be true for the last name, because we are using the delegation here on properties. So I'm gonna create here a user. So I'm gonna type here val user. I'm gonna type equals to user, and I'm gonna type here with, and I'm gonna type user. This is the scope function. I'm gonna put curly braces, and I'm gonna type here first name equals Alex, and the last name equals Dobinka. Now if I output those values in the console, look what happens. So if I type here print line user dot first name and print line, let's actually use again the with scope function. Type here with, let's pass here user curly braces print line first name and print line last name. Now if you run this code, you're gonna see that it's using the overriding functions that we provide in our format delegate. So you have in uppercase letters like we defined here. It's gonna whenever we set the value, it's gonna be set it with it's gonna change the value to lowercase letters. So you get Alex and Obinka in lowercase letters. This is how you can use delegation on properties, and see you in the next video. So now it's time to start a discussion about collections, but first I'm gonna create a new project. I'm gonna call it collections. For the language, select Kotlin. For the build system, IntelliJ. Make sure to have the JDK selected, and also check this box to have the main function auto-generated for us. So I'm gonna click on create to create the project. Now I'm gonna delete this code because we don't need this code, and also I'm gonna hide the project pane. Now, what are collections? Collections are a group of objects stored together in a single variable. They are similar to array, but they are different in some sense. And there are mainly three collections that we're gonna look at, and those are the list, the set, and the map. And those among those collections, they are separated in two groups. So there are mutable list and sets and maps, and immutable list sets and map. And mutable means that you can write to that collection, so you can add or remove elements to it. So that collection can grow or shrink as you add or remove elements to it. And immutable means that you can only add elements only when you instantiate that, or when you create that collection. You cannot add later elements to it. The size is fixed, so you cannot add or remove element. So this is the difference between immutable and mutable, and we're gonna look at all of those in this video. So we're gonna look at the list collection first, and we're gonna look at an immutable list. So we type val. I'm gonna create a variable names, and here we're gonna type, to create an immutable list, type list of. And here we need to specify the type, what kind of data I'm gonna put here. And we'll type name1, name2, and name3. Now, we cannot add or remove element from this list because it's an immutable list, but we can get an element to output in the console, and to do that, we type print line. We type names, we put square brackets, and we get the element by its index, and the index also starts at 0. So let's get the first element. So if you run this code, you'll see name1 outputted in the console. So we get name1. So this is an immutable list. We cannot add or remove elements from it after we instantiate it here. Now let's look at an mutable list, so a list which you can add and remove elements to it. So to do that, we just change this from a list of to a mutable list of. So we type here mutable list of. We can also remove the explicit type here, the explicit type declaration, because it's gray out. So remove that because it can be inferred. And to this mutable list, now we can add or remove the element. So I can type here names, and we have this add function. So we can type add, and here we can pass a new element. So we pass here, let's say, name 4. Now if I let's type here names dot for each, print line, not this for each, names dot for each, this for each, print line. Now if you run this, now you see you have name 1, name 2, name 3, and name 4. So name 4 was added to our mutable list because our list is mutable. We can add or remove new elements. So down here I can type names dot remove, and we can remove an element, and we can remove the element I think by you can use this function remove at, so we can remove the element by its index. So we can type here the index, and that is gonna remove the first element. So if you run this code, name 1 is not gonna be showed. So as you can see, name 1 was removed because we remove it by its index. And we can also remove an element using this function by typing the element. So we type here, let's say, name 2. Name 2 element now is going to be removed. So now if you run this, name 2 was removed. So those are two functions with which you can remove elements from the mutable list. So this is a mutable list. You can add and remove elements to it, and the list is gonna grow and shrink as you add or remove elements to it. So this is the mutable list. Now we're gonna look at a set, and a set is a collection which can store only unique elements, so you cannot have duplicates. So if I delete this in our mutable list, we can put an element which is the same. So we can have two elements which are the same. So if you run this, we have two elements which are the same. You're gonna see name 1 at the end. We have name 1, name 2, name 3, and name 1 again. So we can have duplicates in our collection on our mutable list, but in a set we can't. So, but first we're gonna look at a immutable set, and then at a mutable set. So we type here. Let's delete this. We type here set of, and here we need to pass string. Now if you run this, you will see that name 1 is not shown 2 times here. It's going to be shown only 1 time. So you have name 1, name 2, and name 3. This is because the set is not allowing duplicates in its list. So, and this is a immutable set of. So if I type here names dot add, we cannot add or remove new elements, but we can also use a mutable set of. So we type here mutable set of, and now we can add and remove new elements to it. So we can type names dot add. So here you can add a new element, let's say name so now if you run this, you're gonna see name 1, name 2, name 3, and name 4, and our duplicate is not shown because, as I said, a set can only store unique elements, not duplicates. But if I add objects that we create, look what happens. So let's create some user objects, but first let's create the class user, and it's gonna have a val name is gonna be of type string. Now let's create some user objects here, and we're gonna add to our mutable set. So we type here val user1, gonna type here user, and gonna pass some generic names like name1, and let's press Ctrl D a few times. Let's change this to name2 into 5, and let's add here a val user 6 equals user, and let's type here Alex. Let's press Ctrl D, and let's change this to user 7. Now let's add those to our mutable set. So let's change now the type. So it's gonna store user objects. So we're gonna pass here user1. I'm gonna speed up now this a little bit. I'm gonna press Ctrl Alt L to format the code. Now we cannot add here name4 because now the type is user. Now if you run this, let's actually change this print to it.name, and let's run our code now. And we have name1, name2, name3, name4, name5, and we have Alex 2 times. So why you have duplicates, even though I said that sets can only store unique elements? This is because previously the set actually what it's doing to determine if it has duplicates is using the equals to function that we talked about in our video about data classes. So when we typed only strings, then it was using the equals to function which was overridden inside the string class to determine if there are equal strings. But now, because our class doesn't have the equals to function overridden in its class, it's not it's using the equals to function which is inside the any class. So it cannot determine if two users are equal. And to change that, just let's hide the console and to just put the data keyword here, because now this will generate the equals to function, the two string and the hash code. So now if you run this, now we have Alex only one time, because now it's using the equals to function which was auto generated by the class user, because you put here the data keyword. So this is a good thing to have in mind, that this mutable set is using the equals to function to determine if the objects that you add to yourself are equal. So having this in mind, now let's look at maps. So I'm gonna close this, I'm gonna delete this, let's delete this, let's delete this also. Now let's look at the next collection that you can use in Kotlin, and that is the map collection. And use collection when you want to store key value pairs. So I'm going to create a variable, it's going to be called users, and I'm going to put equals, and I'm going to create first an immutable map. So we type map of, and here we need to specify what kind of type is going to be the key. So the key is going to be an integer, but you can put any class you want here, and the value is going to be a string. So I'm going to store the ID and the name of an user. And to define our element in pairs, here we type first the key, and then we use the to keyword to map our key to its element, so to its value actually. So we type 1, 2, and now the value. Let's first type Maria. So now we have one element stored in paired, and the key is 1, the value is Maria. Next, I'm gonna do the same for the next one. So I'm gonna type here 2, the keyword 2, Alex, and then I'm gonna type 3, the keyword 2. So you need to type the value now. I'm gonna type John. Now, to get one element from this map, we type print line. We type here users, square brackets, and we get the element by its key, as you can see by this hint key. So we get, let's say, the element 1. So now if you run this code, we get Maria, because Maria has because this key is for the key 1, the value mapped, the value which is corresponding to this key is Maria. And if you change this to 2, gonna get Alex. If you run this, so this is an immutable map. In this map you cannot add or remove elements. But if I declare this as a mutable map, so let's change this to a mutable map. So we type here mutable map of. Let's delete this from here. And let's pass here int and string. Now, here now, so you need to put this in parentheses. Here we can add new elements, so we can type users. Actually, first let's loop through our map to see our elements, and I'm gonna use the for each function to loop. So we type here users dot for each, and we choose this one. And inside our loop we add a print line, and I'm gonna put quotation marks, and here we're gonna put $sign. I'm gonna type T, and T is the key, and $sign U, and U is the value. So now if you run this, we get 1 and Maria, 2 and Alex, 3 and John. So we have the key and we have the corresponding values. And you cannot have duplicated keys, and this is very important to know. You can also add or remove elements from this map. So to add an element, you just type users, and we need to specify the key. So we put square brackets, so we type users, square brackets, and then we put a key, let's say 5. And we put here equals to, and here we need to pass a value. So the value is gonna be, let's say, Vlad. Now if you run this, we get 1 and Maria, 2 and Alex, 3 and John, and 5 and the corresponding value Vlad. So Vlad has the key value 5. So you can also remove an element from our map. So we type users dot remove, and you here for this remove function you pass the key of the element that you want to be removed. And let's say that I remove 2, so I remove Alex from our map. So if you run this code, now Alex is not going to be shown here because it was removed on the line 4. So Alex was removed. So this is how you can use immutable and mutable maps. This is how you can add and remove elements, and this is how you can loop through our map. And this is our discussion about collections, and see you in the next video. Now it's time to start a discussion about collections operations, and we're going to look at the first operation, and that is transformations. And we're going to start with the first one called mapping. So I'm going to create a new project. I'm going to call it collections operations. Select Kotlin, IntelliJ, then click on create. We'll go on the left hand side, click on Kotlin, right click, new. I'm going to create a new file. I'm going to call it main. I'm going to create the main function. Now, what are transformations? As the name implies, transformations are some functions with which you can change a specific collection. And we're going to look at the first one, which is called mapping. So I'm going to create first a collection. So I'm going to type val numbers, and it's going to be a set. So I'm going to type numbers equals to set of. And here we're going to define some values like 1, 2, 3, 4, 5. Let's press Ctrl Alt L to format the code. Now I'm going to add a print line here. Now to use the mapping collection transformation, we just type numbers. And one important thing to know here is that those transformation functions are lambda functions. So if you don't know what lambda functions are, I suggest you to watch the section which is called lambda function to first understand what are lambda functions, because it will be very hard for you to understand how those transformations work without understanding how lambda functions work. Now here we're gonna call our transformation function, which is the first one, which, as I said, is mapping, and the function is called map. I'm going to explain immediately what it's doing, and as you can see, it's a lambda function. So I'm going to press enter, and we are inside the curly braces. And here we're going to define our transformation. So what we're saying basically here is, do whatever I type here in this in those curly braces, apply to every element of this collection. So if now to refer to the parameter to a specific parameter from the numbers set, we type it, and I'm gonna type it times 10. So what we are saying here is, do this transformation, so change this set by multiplying every element inside this collection, inside this set, by 10. So if you run this, now every number is going to be multiplied by 10. So if I run this, now we get, instead of 1, 2, 3, 4, and 5, we get 10, 20, 30, 40, and 5. So what this map function and what this it times 10 did is it transformed, it changed our set into what it was changed by the expression that we defined here. So we said that I want every element we said here to be multiplied by 10, and then we display them here. We can go even further. We can put here an if statement. So we can type here if, let's say it, so it refers to a specific element in that list, in that set. So if it equals, so if equals 3, we're gonna say here it times 100. So what we're saying here, if one of those elements inside this numbers set is equal to 3, then multiply it, change it, so change it by this expression, so multiply it by 100. And you can also put the else part. So we put else, we're gonna put it times. So if the else part is true, if the else part is executed, we're saying if the number is not equal to 3 from this list, then multiply the number by 10. So now if I run this, look what we have here. So we have 10, 20, and we have 300 here. This is because this transformation now is using the if and else statements that we define here. So this is what the map transformations allows you to do. You can change, you can transform a specific collection by an expression that you defined inside the curly braces of the map function. All right. Now let's look at how we can use the map transformation with another collection. Let's see how can you use the map transformation with a map. So with a map which has a key and a value. So to do that, we just type here val numbers map. So I'm gonna type val numbers map. I'm gonna put equals. I'm gonna type map of, And here I'm gonna type key 1 2 1, then key 2 2 2, then key 3 2 3, and finally key 4 2 4. Now if you wanna use the map transformation function on the map collection, you can use it either on the keys, so you can use it on the keys, or on the values. So we can type here print line number map, so we choose here dot, and we choose map keys now. So we choose this one, map keys lambda expression, so map keys, that one, and here we type it dot key, so we get the key dot uppercase, so that is gonna uppercase all the keys inside our map. Then we're gonna add another print line here. We're gonna type number map dot map, now we choose map values, and we type here it dot value, so the value plus it dot key dot length. Now if you run this, though this expression is going to be applied to all of our keys inside our numbers map that we defined above, and the second transformation is going to be applied to all the values that we defined inside our numbers map. So if you run this code, now we're going to see the keys being first uppercase, and then we're going to see the keys plus the length. So you see, first we get 10, 20, 300, 40, and 50 for our first transformation that we have here. Then we have our second. Then we have our transformation on the map keys. So we have the key, and then we have the value. We have key, and the key is uppercase because we said to do that by using this expression. So it uppercase all the keys, as you can see here, and then you see the corresponding value for the key. After that, you see you have numbers map.value, so you have it.value plus it.key.length. So you have key, and you have 1, and we have 6. You have key 2, and you have 7. So the key, the value of the key is to the value of the key is added the length of the, so to the value that we have here, we have added the value length of the string key that we defined here. So this way we have 2, then we have 7, then we have 8, and then we have 9. So this is how and you can also do for the map transformation, and to type here numbers dot map, and we choose this one, index not null, and here we choose we have 2 parameters. First is the index, and second is the value. So I'm gonna choose the name for the first one, index, and for the second one, let's call it value. Then we have the arrow, and here we have gonna define our transformation, our expression, which is going to be applied on our numbers. So here I can use the index. So I'm going to type here an if statement. So if index equals 0, then I'm gonna assign. So I'm gonna transform to the we're gonna put that value null to the index 0. Else I'm gonna type index times value. So else you're gonna multiply the index times the value. So if you run this, we get 2, 6, 12, and 20. So for the first one we get nothing because for the first index we assign null, and then it's using the else part to transform our numbers list, and it's multiplying the index by the value. So we first have this indexed 0 multiplied here we have null for the because we checked here, so we have null. So at the index 2 we have 1 times 2, and we have 2. Then here we have at the index 2 we have 2 times 3, so the index is 2, the value is 3, and we get 6 here, and so on. So this is how you can use also the index if you want in your transformation. Now we're going to look at the next transformation that we can do in our collection, and that is zipping. Now it's time to look at the transformation function called zipping. So I'm going to add a comment here called zipping, and I'm going to declare two lists. I'm going to call the first one colors. I'm going to put equals. I'm going to type list of. I'm going to type red, brown, and gray. And I'm going to create another list called animals. Equal list of. I'm going to type here fox, bear, in quotation marks, and wolf. Now, what the zipping or the zip functions allow us to do is to create pairs of elements with the same position in both collections. So we can create pairs with red. We can create a pair of fox and red, a pair of bear and brown, and a pair of wolf and gray. And you can do that just by typing here print line, and you can do this in two ways. You type colors, and you can type dot zip, and you type here animals, and if you run this, you will see them in pairs. So you're gonna see fox red, bear brown, and so on. So you see here red, fox, brown, bear, gray. Also the zipping is used to create pairs, and the pairs are at the same position in both collections. Or if you don't want to use this zip function with parentheses, you can type here colors, zip, and animals, and you type here animals. Now if you run this code, you're gonna see the same output. Now if you want to use a transformation with the zip function, you can type here print line, and you can type colors dot zip. Now I'm going to use the parentheses animals, and now I'm going to put curly braces, so the lambda function here. I'm going to type animal, or let's put first color and animal. I'm going to put the arrow sign, and here I'm going to type de, but I'm going to put first quotation marks, and put the, and I'm going to put $sign, and I'm going to refer our animal parameter that we defined here. So we type here the animal dot, and we call the replace first char function. So we type replace first char, and as you can see, this also is I think a lambda function, and inside of this we type it dot uppercase, and this is gonna uppercase the first letter of the animal that is defined here, and I'm gonna type is $sign color. Right, now if you run this, you're gonna see the Fox, and the F is uppercase because it's uppercase by this expression that we have here. It replaces, and this it refers to the animal variable that is defined here, and it refers to the first letter. So it says it that uppercase, so uppercase the first letter, then return that to the animal variable. And we have the fox is red, so have the color, and then we have the bear is brown, the wolf is gray, and all the animals start with a capital letter like we define here in this expression. So this is the zip function. So this is how you can use the zip function to create pairs, and also you can use the unzip function to unzip a list of pairs. So first let's create a list of pairs. So I'm gonna type val number pairs equals, I'm gonna type list of, and here we're gonna put 1, 2, 1, 2, 2, 2, 3, 2, 3, 4, 2, 4. Now if you want to unzip those pairs that we created, you can just type here print line number pairs. Let's first display them as pairs, and next let's print line, and let's type number pairs dot unzip. Now if you run this, you're gonna see them first in pairs, and then you're gonna see them unpaired because we use here the unzip function. So as you can see here, you have first 1, and you have 1, 2, 2, 3, 3, 4, 4. So you have in pairs first, and then we have them separated. So we have first 1, 2, 3, 4, and then we have the numbers 1, 2, 3, 4. So we unzip them, we separated them. They're not pairs now anymore with this unzip function. So this is how you can use the unzip function. Now it's time to look at the next transformation that we can use, and that is association. Now, what is association? Association transformations allows you to build maps from the collection elements and certain values associated with them. In different association types, the elements can be either keys or values in the association map. We're going to see what this means. And the basic association function is the associate with, which creates a map in which the elements of the original collection are keys, and the values are produced from them by the given transformation function. So let's see an example with this. So I'm going to delete this code because it will make the output hard to understand because they have so many things here. And I'm going to type val numbers, I'm going to put equals, I'm going to type list of, I'm going to type here 1, 2, 3, and 4. Now I'm going to type here print line numbers, and we are going to use the associate with the function. So we type associate with, and this is going to produce, as I said previously, it's going to produce a map in which the elements of the original collection are keys. So the keys of this map are going to be those elements, and the values are going to be produced by what expression we define here inside the parentheses. So I'm going to define here it. So I'm going to type it dot length. So now if you run this, you're going to see the keys being 1, and then you're going to see the value being the length of that specific element. So if you run this, we get the key 1, the value 3, the key 2, the value 3, then you get 3, the value is 5, then you get 4, and the value is 4. So what has happened now is that the associate with function created a map in which the elements, the key are the elements of the collections. So those are the keys inside our map, and the values of those associated with those keys are produced by the expression that we define here, by it.length. So basically gonna use the length of that specific element, and it's gonna be the value. So this is why I have 1, 3, 2, 3, 3, 5, and so on. Now, for building maps with collection elements as values, there is a function called associate by. It takes a function that returns a key based on an element's value. And if two elements keys are equal, only that last one remains in the map. So let's look at this one. So I'm going to type here print line. And I'm going to put here numbers. So we type numbers dot associate by. And now here we're going to define the expression which is going to build the key, because now the associate by function is going to build a collection which the elements now are not keys like we had previously, but they are values. So here in the expression we need now to define how the key for those respective values that we have here is going to be created. So we type here it dot first dot uppercase. So this is what this is gonna do. It's gonna create a key. It's gonna use let's say that we have element 1, and it's gonna take element 1. It's gonna take the first letter of the element 1 and it's gonna uppercase it, and we're gonna have O, and as the key we're gonna have O, and as the value we're gonna have 1, and for the next ones it will be the same. So now if I run this code, as you can see, now the values are now the collection elements are the values here. So they are the values. Previously the collection elements were the keys, and the keys were built by the expression that we defined here by this. So we have O, and we have T, and we have 4, and we have T only one time, and no, we don't have 2 and 3 because you cannot have duplicated keys in a map. So this is why we have only one T here. So this is associate. So this is association. Now associate by can also be called with a value transformation function. And to do that, we just type here print line numbers dot associate by. Now we need to apply a transformation now on the key and on the value. And how gonna do that? We can type here, actually let's delete this because we don't need curly braces. We put parentheses and we type here key, and we have a suggestion, key selector. So we're gonna apply the first transformation on the key. So we type key selector dot name the argument, and we put curly braces, and here we type it, so the key dot first dot uppercase. So now what we're saying here, apply this transformation for every key in the map that is gonna be built. So apply this transformation for every key that is in the map that is gonna be built. So we're saying to uppercase to take the first letter and uppercase it. Then we also need to apply a transformation for the value. We put comma here at the end of our curly brace, and we type here value. You also have a name argument. We put again curly braces, and here we're gonna type it that length. So this is the transformation that is gonna be applied to all the values in the map that is gonna be built. So this is the transformation. So this is how all the keys in in the map that is gonna be built are gonna be changed. So the first letter is gonna take, this thing is gonna take the first letter of the keys and it's gonna uppercase it. This will take the length of all the values in the map that is gonna be built, and it's gonna display the length of that element. So if you run this, we get 0, 3, T, 5, F, 4. So we have the first letter uppercased, and then we have the length 3, then we have T, we have the letter uppercase, and we have the value 5, the length of that element. Then we have F, so we have a 4, and we have the transformation apply on that element, on this element, on 4, and we have the length, and we have 4. So this is how we can use transformations with the associate by function. And next we're going to look at the next transformation function, and that is flatten. Now it's time to look at the next transformation function that we can use, and that is the flatten function. But first, let's see why you'll need to use this flatten function in the first place. So I'm going to add a comment here called flatten, and I'm going to create a variable here. So I'm going to type val, it's going to be called numbers sets, and this is going to be a list with list. So I'm going to type here list of, and inside the list I'm gonna type set of. So we have a list inside of a list, and I'm gonna provide some values to our set of, like 1, 2, 3, then another set of 4, 5, and 6, then another set of 7, 8, and 9. So what we are having now is we have a list within a list, where the index of this list is its own list. So we have a list of sets of ints. Now if you want to loop through this list, if you want to display the elements in this list, it is not that easy, because you will first need to loop, because let's say that, because what we have here is what is called a multi-dimensional array. So more specifically, what we have here is a 2-dimensional array, and at the index 0 we have a list, at the index 1 we have another list, and at the index 2 we have another list. And to navigate to this list, we need to first get inside that list that is at that specific index, to loop to that list, and then we need to move to the next index and to loop to that list, to that next list, which is at that index. But now let's see first how we can access one individual element from our 2-dimensional array, so from our array of arrays. And to do that, to type here print line, I'm gonna put numbers set, and if we put square brackets, and we define the index from which list we want to access the element. And now I want to access the element 9, and the element 9 is stored at the index 2. So we put 2, and let's say that I want I want to access, as I said, the element 9. Now to access the element 9, I need to go within this list and use the index to get the element 9, and the element 9 is stored at the index 2. So I'm going to put square brackets 2. But this, for whatever reason, doesn't work with a list of sets, and we need to change this to array of. Also those, also change it to array of, also array of, and now everything will work fine. So array of. So if you run this, so now we are accessing the index 2, where the array is stored, where our number is stored, and we get the element 2, we get the element 9. So now if I run this, you're gonna see 9 outputted in the console. So we get 9. So this is how we can access one individual element from our multi-dimensional array. So I'm gonna delete this, I'm gonna change it back to a list of and to set of. So let's type list of, set of and set of. And now let's see how we can loop through this two-dimensional array. And to do that, we type here for, and we type numbers. I type specific numbers because this is gonna, as you can see, gonna hold the numbers, the set of numbers, for numbers in number sets. So now we are getting the, as you can see here, this is of type is the type set of ints. So this basically gets the element at the number set index, let's say 0, and it gets the first set. And now we need to loop through that set. So another for number in numbers. So now we are looping through the list, through the set which is inside the list at the index 0, and I'm gonna add the print line to output that number. I'm gonna type here number, and also I'm gonna add a space here. So I'm gonna add the print line here, and I'm gonna type here /n. Now if you run this, as you can see, you have on the output 1, 2, 3, then we have a space 4, 5, and 6, then 7, 8, and 9. But we achieve this by using a loop, and then we use another loop. So we have a loop inside the loop. We have a nested loop in order to get to this two-dimensional array, because as I said, the index of this array is its own list, so it contains a list. Now with the flatten function, what we can do is that we can convert this two-dimensional array in one-dimensional array. So you don't need to use these nested for loops in order to loop through to them. It will return the nested it will provide access to the nested collection elements without you needing to loop through this two-dimensional array. It will basically take that two-dimensional array and it will convert it in one-dimensional array, and you will not need to create to have this nested loop inside. You have to have this loop inside the loop in order to display the numbers. So to do that, we type here val numbers, let's say flatten, equals to number sets, so our list with list, dot flatten. Now if you look at the type here, now this is a list of ints. You no longer have a list of sets of ints. So this is very informative, because it tells us that this now is just simply a list of ints. It's not a list with a set which itself is also a list of ints. So this converts that two-dimensional array in one-dimensional array. And because of that, now it's much easier to get one element from our list, because now our list is not a two-dimensional array, it's just one-dimensional array. So if I type here print line, and let's say that I want to get the element 9, I'm gonna type here numbers flatten square brackets, and I'm gonna type here 8 because it's stored at the index 8. So now if I run this, so we get 9 here. And as you can see, this is much easier than with the two-dimensional array. So this is what the flatten function is doing, is converting the two-dimensional array, or if you have a multi-dimensional array, into one-dimensional array. So now let's look how we can loop through our one-dimensional array. So let's delete this. And if you want to loop through this, you just type for number in numbers flatten, and we add here a print line number. And let's comment this code. And if you run this code, now we get the number displayed one after another, so we get 1, 2, 3, 4, 5, 6, 7, and 9. And we got this because our function, our flatten function, our transformation flatten function is transforming, is converting our two-dimensional array in one-dimensional array, so it's easier for us to get the elements and to loop through them. So this is what the flatten function is doing. And next we're gonna look at the string representation and the functions that we can use for the string representation. I'm gonna close the console. Now it's time to start a discussion about string representation. So if you need to retrieve the collection content in a readable format, you can use functions that transform the collections to strings. And there are two functions to do that, the join to string and the join to. The join to string builds a single string from the collection elements based on the provided arguments. The join to does the same but appends the result to the given appendable object. And what that means is that it's gonna add the text to the object on which that function, the join to function, is called. You're gonna see an example with this immediately. And now I'm gonna create a variable called numbers, val numbers. I'm gonna put equals. I'm gonna call it actually numbers strings equal, and I'm gonna type here list of, and I'm gonna put here the text 1, 2, 3, and 4. Now, if you want to retrieve if you want to get the string representation of this list, if you just type here print line, and we put here numbers strings, and if you run this, we get 1, 2, 3, and 4. But this I think is calling the toString function. It's not because we're not using the join toString function, and I don't like those square brackets. I want them to be separated by comma with spaces. To get that, just type here print line. So let's put here print line, and to type numbers to string dot join to string, and we delete this and we put parentheses. Now if you run this, you'll see now the string representation of our list. They are gonna be separated by comma, when with it's gonna have spaces. Now let's look at the join to function, and for that I'm gonna define another list down here. So I'm gonna type here, let's press Ctrl Alt L to format the code. So I'm gonna type here val is gonna be called list string, and now I'm gonna use something called a string buffer, and this is like the string type is a little bit different, but it's gonna allow us to do it's gonna allow us to present how the join to function works. So string buffer, and we put parentheses, and here we define our text, and we're gonna type the list of numbers, and I'm gonna put colon. So we type here the list of numbers colon. Now to use the join to function, we just type here another print line. We type number strings dot join to, and as you can see, this receives a buffer, and this is the buffer that we created here. So I'm gonna press enter, and we're gonna give us the argument, the list string that we created. And what is this? This is gonna do is gonna append this text that we have here in front of all of our elements that we have in our list number strings. So now if you run this code, as you can see, it added the text, the list of numbers that we have here, to our number strings in front. So we have the list of numbers 1, 2, 3, and 4. Now, if you want to build a custom string representation, you can specify its parameters in a function arguments, which are the separator, prefix, and postfix, and the result will start with the prefix and end with the postfix, and the separator will come after each element except the last. So let's see how we can do that. So I'm gonna use the numbers to string. So I'm gonna type here print line numbers to string, and we type join to string, and we select this one with the with the separator parameter, and we type here separator. So now we define what is going to be the separator here, and we're going to put quotation marks, and we're going to put this. So this is going to be our separator between our elements. Next, we're going to define the prefix. So we put here comma, we type prefix, and now I'm going to put the prefix, and the prefix is going to be the text start and colon. So we put quotation marks, start, and colon. And we also need to provide the postfix, and to do that we put another comma here. So those are named arguments which are defined in this function join to string. So we type here postfix, and we put colon end. Now if you run this, you're going to see them separated by this separator that we define here. It's going to have the prefix start, and it's going to have at the end this postfix, which is comma and end. So now if you run this code, as you can see, we have start and we have 1, then it's separated by the sign that we define here. Then we have 2, 3, 4, and we have the end. So we have our postfix that we had defined here. Now, for bigger collection, you may want to specify a limit, so a number of elements that will be included into the result. And if the collection exceeds that size, that limit, all the other elements will be replaced with a single value called the truncated argument. So let's see what all of this means. So let's say that I have a list called numbers. Let's type here val numbers, and I'm going to create a range from 1 to 100. So what we have here is 100 numbers. And let's say that I type here print line, but first let's convert this to a list. So I'm going to put this in parentheses. So you put this in parentheses, and you put at the end dot to list, and this is going to convert now our range into a list. And now as you can see, the type is a list of ints. And now if I type here numbers, and if I run this code, we're gonna get all of our numbers displayed. Now, with as I said, with the join to string function, we can specify a limit and also a truncated, which is gonna be the thing which is gonna be showed out after our number limit. So what I can type here is I can type join to string, and we choose also one with parentheses. So here we type limit, the named argument limit, and let's say that I don't want to get all the numbers, as you can see here, from to 100, and I want to get only the first 15 elements. To do this, we just type here limit 15, then we type truncated, and that is going to be this truncated thing is going to be showed after our limit number. So I'm going to put here quotation marks, less than sign, dot dot, and greater than sign. So now if you run this, look at what we have in the output. Now we only have the first 15 elements, and then for the next elements we only have this string that we typed here, this expression that we have here. And we can change this. You can change this, let's say, to 25. So if you run this now, you'll see only the first 25 elements displayed. So this is how you can use the join to string with the limit name argument and with the truncated. Now, let's say that you want to customize the representation of elements, of the elements themselves. You need to, in that case, you need to provide the transform function. So what we can do is that we can type here print line, let's say, and I'm gonna type number strings, put dot, join to string, and we choose this one with curly braces. And here I'm gonna define how this list is gonna be transformed, so how it's gonna be changed. So I'm gonna type here quotation marks, element, and I'm gonna put colon, we're gonna put dollar sign, I'm gonna put it dot uppercase, so we're gonna uppercase all the elements. So if I run the code now, now get element and get one. So you get one uppercase, and element, you get 2 uppercase, element 3 uppercase, element 4 uppercase. So this is how you can use the transformation. This is how you can transform your list using the join to string function. So this is our discussion about the string representation, and now I'm gonna move to the next section. So I'm gonna end the video now. Now it's time to start a discussion about filtering. So what is filtering? Filtering is one of the most popular tasks in collection processing. In Kotlin, filtering conditions are defined by predicates, and that is lambda function that take a collection element and return a boolean value. True means that the given element matches the predicate. False means the opposite. The standard library contains a group of extension functions that let you filter collection in a single call. Those functions leave the original collection unchanged, so they are available for both mutable and read-only collections. To operate the filtering result, you should assign it to a variable or chain the function after filtering. Now, the basic filtering function is filter. When called with a predicate, filter returns the collection elements that match it. For both list and set, the resulting collection is a list. For map, it's a map as well. Now, let's define a variable here called numbers. So let's type here val numbers. I'm gonna put equals to list of, and I'm gonna type here 1, 2, 3, and 4. Now, if you want to filter this list, what you need to do is, let's create another variable here called longer than 3. I'm gonna put equals, and I'm gonna type numbers dot, and we type filter. So filter, and we choose this one. And here we defined how our list, so we could define the expression which is gonna determine how our list is gonna be filtered. So I'm gonna type here it, so the element dot length, let's say greater than 3. Now, if I add a print line down here, print line. Now this list is gonna contain all the elements from our numbers list which are longer than 3. So if I put here longer than 3, and if I run this, we get 3 and 4, because those are the only string numbers which have a length longer than 3. So I'm gonna close the console. Next, let's see how we can filter a map, and for that I'm gonna create another variable called numbers map. I'm gonna put equals to, it's gonna be equals to map of, and I'm gonna define here the key is gonna be a string key 1, the value is gonna be 1, comma, then key 2, 2, 2, then key 3, 2, 3, and now I'm gonna put key 101 to 101, the value. Now if you want to filter now this map, I'm gonna create another variable called filtered map, and it's gonna be equal to our numbers map, but it's gonna be filter. So I'm gonna type dot numbers map dot filter, and now I'm gonna filter the map both by the key and by the value. So we type here it dot key dot ends with, so we want to filter it first by the key, and we want that key to end with a specific character, and that character is going to be 1. And so we put the operator and we want the value to be greater than 100. So we put here it dot value greater than 100, and the only key which satisfies this condition that we define here is this key. So now if I add a print line here, and if I type filtered map, so the map which was filtered using the expression that we define here, now if you run this, you're gonna see this in the output, because this is the only one which satisfies the condition. So we get key 101 and we get the value 101. So this is how you can filter a map using both the key and the value. Now the predicates in filter can only check the values of the elements. If you want to use element position in the filter, use filter indexed. It takes a predicate with 2 arguments, the index and the value of an element. To filter correction by a negative condition, use filter not. It returns a list of the elements for which the predicate yields false. So let's see how we can do this. So I'm gonna declare 2 variables down here. Val filtered index is gonna be equal to numbers, or a variable that is defined above, dot filter index, and this is gonna take 2 parameters, index and the value. So I'm gonna type here, actually we need to put curly braces, index, let's change this to value, actually let's keep it as S, Control Z, and here we're gonna define our expression by which our list is gonna be filtered. So I'm gonna type here that first I want the index to not be equal to 0, and I also want that the value of the element. So actually let's change this to value to make more sense. So let's type here value, because we're talking about those ones. So I want the value of that string, so the value dot length, I want it to be less than 5. Alright, so this is the transformation. If you want, this is not a transformation, this is how we want to filter our numbers list that we define above. I want to filter both by the index, so this is why we use the filter index, and also by the value. And I want the index to not be equal to 0. This is the first condition for the filtering. And I also want, so we use the AND operator, that the value of the element, the length, to be less than 5. Now, if I print this, so if I added here a print line, but first let's also use the filter not. So I'm gonna type here val. So val filtered not and I'm gonna type equals numbers dot filter not curly braces, and we type here it dot length, so the value of the element to be less than equal to 3. Now if we output those two in the console, so if I add here print line and I'm gonna output filter index, this should be filter index, so let's refactor this. So let's type here index. I type it wrong. So let's type here index, actually it will make more sense, but I have index, so why? Anyway, so I'm gonna output that first, then I'm gonna add here a print line, and I'm gonna type filtered not. And filter not, as I said, is gonna return a list of the elements for which the predicate yields false. Now, if you run those two, look what you're gonna have on the output. So this is the output for our first, for this print line and for this print line. So let's think about what we have here. First we have 2 and 4, and we define the filter here. First, the index should not be equal to 0, so the 1 is first excluded, and we also want the value dot length to be less than 5. So the only ones which for which the value is less than 5 is the 2 and 4, because the length of the tree is bigger than 5, because it has a length of 0, 1, 2, 3, 4, and the length is 5, but I want the length to be less than 5, not less than equal than 5. So this is why this is not included, and you only have 2 and 4. Next, now use the filter not, and it's gonna, as I said, it's gonna return a list of elements for which the predicate, for which this expression is gonna yield false. So it's gonna go through all of our elements, and it's gonna return the elements for which this is false. So we get 3 and 4 because those are the only ones which are not less than equal to 3, they are greater than equal to 3. So this is why we have here 3 and 4, because this returns the elements if the length of the element is less than equal to 3. So this is why we get here 3 and 4. And there are also functions that narrow the element type by filtering elements of a given type. So there is a function called filter is instance, which returns a collection of elements of a given type being called so let's see how you can use that. But first let's create a val mixed, let's call it mixed list. I'm gonna put equals, and I'm gonna type list of, and I'm gonna define some mixed elements here. So I'm gonna type here, let's say 1, 2, 3, then some chars like A, B, C. Now some strings, let's type here hello world, another string Alex, and let's also type a boolean. So let's type here, let's say false. Now there is a function, as I said, which narrows the element type by filtering the elements of a given type. So we can use this function called filter is instance. So what we can do here is we can type mixed list dot filter is instance. So we choose I think this one, not this one. Filter is instance. So why? So mixed arrays dot filter is instance, and here we inside the angle brackets we define the generic type for which this list is gonna be filtered. So let's first choose the char, then I'm gonna put dot for each, so I'm gonna use the for each loop, and I'm gonna add print line, and I'm gonna type it here. So I'm gonna type the parameter, which is the it char. So now if I run this, we will get only the chars being displayed here, because it is filtering by using the instance of chars. So you get the chars. If I change this to int, now I'll get the integers from our mixed list. So if I run this, now get the integers 1, 2, 3 that we have defined here. And if I change this to, let's say, string, I will get the strings inside our mixed list, because filter is instance, is gonna take the specific type that we type here, and then it's gonna loop through all of the types which are of this type in this list. So if I run this, I'm gonna see hello world and Alex. So we get hello world and Alex. Also I can filter for boolean values. If I type here boolean, it's gonna output in the console the one boolean value that we have here, which is false. So if I run this, I get false. So this is how you can use the filter is instant function on types to filter the mixed list. And you can also put dot, because this returns a list, this entire thing, a filter list. You can put dot for each to call this for each lambda function, and then you output them in the console. The next thing that you can look and that we're gonna look at is called partition. So I'm gonna add a comment here, but I'm gonna hide the console first. So I'm gonna put here a comment, and I'm gonna type here partition, partition. So partition, and this is another filtering function called partition, and it filters a collection by a predicate, and it keeps the elements that don't match in a separate list. So you have a pair of lists as a return value. The first list is containing the elements that match the predicate, and the second one is containing everything else from the original collection. So we're gonna take again our numbers that we have defined above. So I'm gonna type here val, and to get this partition we put parentheses, and here we type match. So this is gonna be the values which are gonna be matched by the predicate, and I'm gonna type here rest, and here gonna be stored the rest of the values which don't match the expression, the predicate that is gonna be defined. And I put here equals numbers dot partition, and we type here it dot length greater than 3. Now if I add a print line here, I can print first the match. Let's press Ctrl D, and now I can print the rest of the elements which don't match this condition, this expression that is defined here. So if I run this code, you will see first all the elements which are greater than 3, and then we're gonna see the rest of the elements which are not greater than 3. But let's add a space here to make things more clear. So I'm gonna add here a print line, quotation marks, /n. So let's run this again. So we get 3 and 4. So those are the elements which are coming from our match list, which is defined here. Which satisfy this condition, which is greater than 3. So we have 3 and 4, so the length is greater than 3, and then we have 1 and 2. So those are the rest of the elements which are not satisfying this condition that is defined here. So we have 1 and 2. So this is how you can use the partition function to get basically to get a pair in which the return value, the first is the list containing the elements that match the predicate, and the second is the one containing everything else from the original collection. So this is how you can use the partition function. So now I'm gonna end the video and see you in the next video. Now it's time to look at testing predicates, and those are functions that simply test a predicate against the collection elements. And we have 3 functions: any, which returns true if at least one of the elements matches the given predicate. Then we have none, which returns true if none of the elements match the given predicate. And then we have all, which returns true if all of the elements match the given predicate. So let's test all of them. So I'm gonna type here print line numbers dot, let's start with any, so we put any. So here we type it dot ends with, and let's say e. Then add another print line numbers dot none, it should be curly braces, it dot ends with, let's say w, and print line numbers dot all, let's say it dot length. So if the length of all the elements is greater than 1. So now if you run this, all of those are gonna return either true or false. So we get true, true, and true. This is because first we're testing any, and this returns true if at least one of the elements matches the given predicate. So it's true. We have 2 elements which ends with e. We have 3 and 1. So this is why it returned true there. Then we check to see if none of the elements ends with w. So we check to see if none of the elements in our numbers ends with w, and it's true. None of our elements ends with w. So we have true in the output. Then we check numbers.all. So we check into if all the elements, the length of all the elements, the element strings that we have here, 1, 2, and 3, are greater than 1. And it's true, all of them are greater than 1. So this is why I have true, true, and true. So this is how you can use the test predicates on your collections. Now it's time to look at the plus and minus operators. So in Kotlin, plus and minus operators are defined for collections. They take a collection as the first operand, and the second operand can be either an element or another collection. The return value is a new read-only collection. And let's look at an example with this. I'm going to type here val numbers. I'm going to put equals to. So now I'm going to type here mutable list of. So mutable list, a list to which you can add and remove elements. And I'm going to type here 1, 2, 3, and 4. Now if you want to add an element to this list, you need to type here numbers dot add, and here you need to specify, let's say 5, and now this new element is going to be added to the list. But with the plus and minus operator, we can do this in another way. So you can type here but I'm gonna put this in another list. So you can type here val plus list. So we put equals to, and we type numbers plus, and we type 5. And now this element is gonna be added to our list that we have here. It's gonna be added to the string 5, and it's gonna be stored in this plus list. Now let's look at the minus operator. So you type here val. I'm gonna call this minus list, and I put equals to, and I'm gonna type numbers. So now I'm gonna use the minus operator. So I put minus, and we type minus mutable list of, and we put here, let's say 3 and 4. So we type here 3 and 4. I have an underline. Let's see what it says. Now, anyway, let's run our code to see what we get in the output. But we need to add some print lines to get something in the output. So I'm gonna add here a print line, plus list, and another print line, minus list. Now if I run this again, we get 1, 2, 3, 4, and our 5 element added to our numbers list from our class list, which is outputted here. And then we get 1 and 2 because 3 and 4 were removed using the minus operator. So this is how you can use the minus and plus operators with collections. So this is our discussion about the plus and minus operators, and we're gonna move to the next section. So I'm gonna close the console and I'm gonna end the video. Now it's time to start a discussion about grouping. So the Kotlin standard library provides extension functions for grouping collection elements. The basic function group by takes a lambda function and returns a map. In this map, each key is the lambda result, so the result of that expression inside the lambda function, and the corresponding values is the list of elements on which this result is returned. This function can be used, for example, to group a list of strings by their first letter. You can also call group by with a second lambda argument, a value transformation function. In the result map of group by with 2 lambdas, the keys produced by key selector function are mapped to the result of the value transformation function instead of their original elements. So let's see what all of this means by looking at an example. So if I type here val numbers, and I'm gonna put list of, again 1, 2, 3, 4, and 5. Now I can add here a print line. I can type numbers, and I can type here dot group by, and I'm gonna group it by it dot first, so the first letter in one of our elements, dot uppercase. And now I'm gonna look at the next group by with the key selector and with the transformation function. So I'm gonna type here print line numbers dot group by. So we have this one key selector. So we type here key selector equals, and here we put curly braces, and we type it dot first, so the first letter in our element, so first it should be here. We put a comma, and we type value, so the value of the value of this list are gonna be transformed. And here we also put curly braces, and we put it dot uppercase, so put it curly braces, it should be it dot uppercase. Let's press Ctrl Alt L to format the code, and now let's run our code to see what we get in the output. So we get for the first one numbers that group by for and we have this lambda it dot first dot uppercase. It takes the first letter in uppercases, so you get so then you get 1, we get T, we get 2, we get F, we get 4, we get then we use this one on which we we group elements with a second lambda argument with a value transformation function, and the result map of group by with two lambdas are the keys produced by the key selector, and the function are mapped to the result of the value transformation function. So the results are mapped to this transformation that is defined here. So this is what creates the keys. This is what creates the keys, this lambda function, and this is what creates the values. So we get O because you get it that first, so the first letter, and get 1 because this is the value. So the value is uppercase. We get 1. So we get 1 here. Then we get again it that first for our element, so we get T, then we get 2, and I get uppercase, then we get F, lowercase f, and we get 4 and 5. So this is our discussion about grouping, and my suggestion for you is to play with the code. Try different values for the key selector, for the value transform, for try to group the elements by different expressions, and just play with the code until you get comfortable with the code. Now it's time to start a discussion about retrieving collection parts. And the Kotlin standard library contains the extension functions for retrieving parts of a collection. These functions provide a variety of ways to select elements for the result collection, listing their position explicitly, specifying the result size, and others. And I'm going to start with the first function called slice, which returns a list of collection elements with given indices. The indices may be based either as a range or as a collection of integer values. So I'm going to create first the main function. I'm going to type val numbers. I'm going to create a list of, and I'm going to type here 1, 2, 3, 4, 5, and 6. Now to use the slice function, we simply add here a print line, and we'll type here numbers dot slice, and we create here a range. So we type 1 dot dot 3, and next we're gonna add another print line, and we're gonna type numbers dot slice, and we're gonna put here now 0 dot dot 4, and I'm gonna type step 2. Alright, so it should be slice, not sublist. So slice here. Slice. And I'm gonna add another print line here. Numbers dot slice, and I'm gonna add now a set here. So I'm gonna type set of, and I'm gonna type 3, 5, and 0. So let's press Ctrl Alt L to format the code. Now if you run this code, look at the output. So you first get the first 3 elements. We get 2, 3, and 4 because we starting from the index 1, so we get 2, 3, and 4. Then we get from 0 to 4, so we get 1, but we don't get the 2 because we have this step 2 which steps the second element. And then we have 3 and 5 because it's stepping for the 4. So this is what step 2 is doing here. And next we have a number slice, and we get 4, 6, and 1, but we get them as the string representation. We don't get them as as integers. So all right, now let's look at the next functions, and those are the take and drop. And to get the specified numbers of elements starting from the first, you can use the take function. For getting the last elements, use the take last. When called with a number larger than the collection size, both functions return the whole collection. To take all the elements except a given number of first or last elements, call the drop and the drop last function respectively. So I'm gonna add some print lines here. I'm gonna add print line, and I'm gonna type numbers dot take 3, another print line, numbers dot take last, also 3, then another print line, numbers dot drop 1, and another print line, numbers dot drop last 5. Now if you run this code, look what you get in the output. But let's add a space here, so I'm gonna add a print line, quotation marks, /n. Now let's run this code again. So we get numbers take 3, and this function basically takes only three elements from our list. Then numbers take last 3 is gonna take the last 3 elements from our list. So we have 4, 5, and 6. Then we have print line numbers drop 1. So we have 2, 3, 4, 5, and 6, and the first element is dropped. So this is what this function is doing. Next we have numbers dot drop last 5, and this function is basically dropping all the last 5 elements, and we have only the 1. So this is what those functions are doing. You can also use predicates to define the number of elements for taking or dropping, and there are 4 functions similar to the ones described above, and those are take while, take last while, drop while, and drop last while. And let's look at all of them, but I'm gonna put a space between our code that we have here. So I'm gonna add the print line here, quotation marks, /n, and I'm gonna add here a print line. So I'm gonna type here numbers dot take while, and here we define the predicate. I'm gonna type not it dot starts with f in quotation marks. Now another print line, numbers dot take last while, and we define here the predicate it not equal to 3, not equal to 3. Another print line, we type numbers dot drop while, and we define the expression, the predicate, which is going to be applied for our drop last while. So it should be drop while here, and we type it dot length equals to 3, and we add another print line, numbers dot drop last while, and we type here it contains quotation marks I. Now if you run this code, we first get 1, 2 and 3. So because here we checking, because we're using the logical not operated, we want all the elements which don't start with F. So we don't have 4 and 5, we have only 1, 2 and 3. Next we have numbers that take last while, and we define the expression for which is gonna be returned the elements by it not equal to 3. So we only have 4, 5 and 6, and the 3 is missing, and we don't have 1 because take last while only takes the last elements. So this is why we have only 4, 5 and 6, and you don't have 3. So it doesn't care about the first element or about the second element. Next we have numbers drop while it that length equals to 3, and here we have so it that the length equals to 3, and we have 3, 4, 5 and 6. So this condition is satisfied. So it basically drops all the elements which are equal to 3. So we have 3, 4, 5 and 6, and all of those are bigger than 3, and the ones which are equal to 3 respectively 1, 2 and let's see, and 6. Actually 6 is appearing here. So 1, 2, I don't know why 6 is appearing, but this is basically saying that it should drop while it that length equals to 3. So it basically drops all the elements which are equal to with the length 3. So we have, this is why we have here 3, 4, 5 and 6. 6 should not be, but I don't know why it's here. Now the next that we have here is numbers drop last while. So again, this is specifically about the last element. So it contains I. So we get 1, 2, 3 and 4. So because this drop last while is basically dropping all the elements or the last elements which contain contains I. So we have 6, 5. So we have drop last while. So we have it that contains I. So it drops all the element which contains I. So sorry for what I said previously. So this is why I have here 1, 2, 3 and 4, and the 5 and the 6 are missing because it basically drops all the elements which contains the letter I. So this is how you can use the take and drop. The next function that you can use is called chunked. And if you want to break a collection into parts of a given size, then you can use the chunked function. Chunks take a single argument, the size of the chunk, and returns a list of the given size. The first chunk starts from the first element and contains the size of the elements, and the second chunk holds the next size elements, and so on. The last chunk may have a similar size. So if I have here, let's change this to numbers strings, and let's type here val numbers. While I was changing that, I should use refactor. So let's use refactor, rename numbers strings, so it will be changed in all the places where we're using that. And here we have numbers, and I'm gonna put equals, and I'm gonna put parentheses 0.13, and I'm gonna put that to list to convert this to a list. And we add a print line to see how this chunk function is working. So we add a print line. Let's close the console, and to type here numbers dot chunked, and would put 3. So it's gonna chunk our elements into 3, into basically elements of 3. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and they are both on chunks of 3 elements. So this is what this chunks is doing. So this is why I have here this result. And the next function that we're going to look at is called windowed, and we can also use a transformation on our chunked element. So I can add here a print line. We type numbers dot chunked, which we also choose the size 3. Then you put curly braces, and here we're going to define how our chunked elements are going to be transformed. So we put it dot sum. So it's going to sum the chunked elements. So if I press Ctrl Alt L to format the code, and now if I run this, look what we're going to see in the output. So we get you get first the chunked elements here in three elements, and then we have our chunked elements, but they are summed up. So we have first 3 because 0 plus 1 plus 2 is 3. Then we have 3, 4, 5 because that is 12. Then we have 6, 7, 8, and we have 21. Then we have 10, 11, and 9, and we have 30, and so on. So this is how you can use the chunked function to chunk elements together by a given size, and you can also use the transformation function to do a transformation on them, like adding them. So as you can see, we have added them here. Next, we're gonna look at the next function that we can use, and that is called the windowed function. And we can retrieve all possible ranges of the collection elements of a given size with the window function. The function of getting them is called windowed. It returns a list of element ranges that you would see if you were looking at the collection through a sliding window of the given size. Unlike chunked, window returns element ranges, windows, starting from each collection element. All the windows are returned as an element of a single list. So if I have here let's create another variable here. Let's call it val numbers string 2, and I'm gonna type here let's say or I can assign the number strings here. So I'm gonna type here number strings. Now what I can do here, I can add a print line, and I can type numbers strings 2 dot windowed, and we choose, let's say 3, and let's see what we have on the output. So now if you run this code, I should have added here a space. So let's add a print line here, backslash /n. So we have 1, 2, 3, then we have 2, 3, 4, we have 3, 4, 5, and 4, 5, 6. So this is similar to chunk, but Windows provides more flexibility because you can specify a step which defines a distance between the first element and to a adjacent windows. By default the value is 1, so the result contains windows starting from all elements. If you increase the step to 2, you'll receive only windows starting from the odd element, first, third, and so on. And finally, you can apply transformation to the return ranges right away. To do this, you provide the transformation as a lambda function when calling window. So it's similar to chunked. And so with this, I think we end our discussion about retrieving collection parts, and see you in the next video. And if you find this confusing, don't worry, because it's so confusing for me and for probably other people, because it takes time to get used to this. And my suggestion for you, just play with the code, change the parameters, play with the functions, try different values and so on. So see you in the next video. Now we're gonna look at some functions with which you can retrieve single elements from our collections. And the first one is one which retrieves an element by its position. So I'm gonna create val numbers again. Numbers equals to list of, and we type here 1, 2, 3, and 4, and also 5. And let's say that I want to get the element at position 3. To do that, just add here a print line, and we type numbers dot element at, and here you specify the position 3, so 0, 1, 2, 3. So we're going to get 4 outputted in the console. So we get in the output as expected 4. Now there are also two functions for retrieving the first and last element, and to do that, just add another print line here and type numbers dot first. So this is going to retrieve the first element, and Control D, numbers dot last. So this is gonna retrieve the first element 1, and last is gonna retrieve the last element 5. So if you run this, we get first 4 from our this print line, then we get first 1, and again the last 5. And we can also retrieve elements by condition. So I can type here, I can type down here, or I will type it here. Actually, I'm gonna type it down here. So now add here a print line, numbers, let's say, dot first. And now I'm gonna retrieve by a condition. So I'll type first, I'm gonna choose this one with curly braces. And the condition is that I want to retrieve the first element for which the length is greater than 3. So I'm gonna type here it dot length greater than 3. And I'm gonna add, I'm gonna press Control D, because I'm gonna do the same thing for the last. So I'm gonna retrieve also by condition. So I'm gonna type here numbers dot last, but I'm gonna change the condition. I'm gonna change it to it that starts with the letter F. So now we're retrieving the first element, which is greater than 3, and next we're retrieving the last element, which starts with the letter F. So now if you run this, we get 3 and 5, because 3 is the first element which is has a length greater than 3, and again we get 5 because this is the one, the last element which starts with the letter F. And if you can add a space here if you want to make things more clear. So I'm gonna add the print line, quotation marks, backslash n, actually /n. So if you run this, we get 3 and 5 output in the console. And we can also retrieve a random element from our numbers. So I can type here print line numbers dot random, and this is going to return a random number from our list of numbers. So if I run this, we get 1. And if I run this again, we get 4. So every time you run this, you'll get a random number. And you can also check if the list is empty. So we can type here print line numbers that is empty. And that is going to return true if the list is empty. And if the list is not empty, it's going to return false. So if you run this, we get false. So this is our discussion about how to retrieve single elements. See you in the next video. Now it's time to start a discussion about aggregate operations. So Kotlin collections contains functions for commonly used aggregate operations. And those are operations that return a single value based on the collection content. Most of them are well known and work in the same way as they do in other programming languages. And we have min or null and max or null, which return the smallest and the largest element respectively. And on empty collections, they return null. Then we have average, which returns the average value of elements in the collection. Then we have sum, which returns the sum of elements in the collection of numbers. And we have count, which returns the number of elements in a collection. So let's declare a list, numbers, list of, let's put some numbers here, like let's say 6, 10, 14, 4, let's say 100. Now let's press Ctrl Alt format the code, and let's add the print line here. Let's put quotation marks and let's type the sum is $, and we type here numbers dot sum, numbers dot sum. All right, and I'll add another print line, and now this is gonna say the count is, again $, numbers dot count. Another print line, the average is, again $, numbers dot average. Another print line, and now I'm gonna say the max value is, again $, numbers dot max, numbers dot max or null. And other print line, the mean value is $, numbers dot mean or null. Now if you run this code, you're gonna see in the output the corresponding values for those expressions that we have here. So again, the sum is 134, the count is 5 because we have 5 elements here, the average is 26.8, the maximum value is 100, and the minimum value is 4. So this is how you can use those aggregate operations and those aggregate functions. And beside the regular sum, there is an advanced summation function called sum of that takes a selector function and returns the sum of its application to all collection elements. And let me show you how this works. So you just type here, so we type here print line, the sum is, $ numbers dot sum of, we select this one, and here you type it times 2. Now if you run this, what it's gonna do is gonna sum all the numbers like the first function that we have here. So it's gonna sum 134, and it's gonna multiply that that number by 2. So if you run this, we get 268, which is 132 times 134 times 2. So this is how you can use the sum of with this transformation, which is gonna basically multiply the list with a number, with the sum of the list with a number. So this is our discussion about aggregate operations, and see you in the next video. Now it's time to start a discussion about ordering, and in this video we're gonna look at comparable and at comparator interfaces. So first I'm gonna create a list of numbers, and I'm gonna declare a mutable list, so mutable list of, and I'm gonna define some numbers here, not in a specific order. So we type 2, let's say 5, 1, let's say 40, 20, 100, let's say 60. Now, what if I want to order the numbers that I have inside our list numbers? To do that, you just you type numbers dot, and there is a function called sorted. So if I type numbers dot sorted, now our numbers are going to be sorted. So if you type here for each, print line it. So now if you run this, even though we didn't type our numbers in ascending order, they're going to be sorted. And as you can see, they are sorted. We have 1, 2, 5, 20, 40, 60, and 100. So they are sorted by this function called sorted. And why this is working? This is working because if you click on this sorted function, or actually if you type here, let's say that I put a type here, int, and if I click on the type, this type integer, this class is implementing this thing called comparable, and this comparable has a function called compare to. So when we actually type numbers that sorted, what internally was happening is that the integer class was using the compare to function, which is a function which you need to implement if you implement the comparable interface, to compare to compare our numbers, and to based on that to swap them, to sort them. And now let's say that I have a data class called laptop, and it's gonna have a variable called brand, gonna be of type string, another variable called year. This could be the year when this specific version was released, an int, RAM, so val RAM, also an int, and the val, let's say price, also an integer, right? Now if I create here a list of laptops, so if I type here var laptops equals to mutable list of, and I type here laptop, let's say that I type here Dell, and I put the year, let's say 2021, the RAM, let's say that is 4 gigabytes RAM, and the price, let's say that is $600. Okay, comma, I'm gonna create another laptop here, so another object, I'm gonna type here, let's call it Acer. It's gonna be, let's say, the year, let's put 2020. the price, let's say the RAM, let's say that is 8 gigabytes RAM, and the price, let's say that it's $100, comma, and let's create another laptop object. So we type laptop, and we create an Apple laptop, which you're gonna choose the year, let's say 2022, and for the RAM, let's say that I choose 16 gigabytes RAM and $1,000 for the price. Now, if I type here laptops that sorted, let's say that I want to sort the laptops, as you can see, while I'm typing, the IntelliJ is not giving me any hints to have this function sorted to fill in that function, because that function is not working on our laptops list. And why is happening that? That is happening because the IntelliJ doesn't know how we want to sort this laptop list that we have here, because you can sort it in many ways. You can sort it by the name, you can sort it by the year, you can sort it by the RAM, you can sort it by the price. So when you say laptops are sorted, the IntelliJ is not knowing what do you mean, because previously it was working with our integers and with our integer class, because the integer class, if you put the type here back integer, the integer class or the int class, what it was doing actually, it was inheriting from this comparable interface, and it was implementing the compare to function, which is used when you call the sorted function. And inside this compare to function, it has defined its own logic for comparing integers, for comparing whole numbers. And what we need to do in order to be able to sort our list of laptops is we need to implement the comparable interface, and we need to define our own logic, which is going to determine how our list is going to be ordered, by which property, by the year, by the RAM, by the price. So this is what we need to do. And to do that, you just put here colon, and we implement the interface comparable. So we type here comparable, and we have a suggestion, we choose this one. We put angle brackets, and here we type laptop, because we want to implement this, we want to compare laptops. So laptops. So this is why we put laptop there. Then we put curly braces, and now we need to implement the function. So click on that, it says implement members, and you have the compare to function. Now, here we need to define our logic, which is gonna determine what makes here we're going to define a logic which is going to determine how our elements is going to be ordered, by what criteria. And I'm going to order the laptops first by the price. And to do that, you just type if, and to type this, and we typing this because this is going to be called on an instance of our laptop class. It's going to call the compare to function, and it's going to compare with another argument. So if this dot price, we say here, is greater than other dot price, we return a positive number. So we type return 1, and positive value simply shows that the receiver object, so the object, this object is greater than the object which was passed. So this is what this means, this one. Else if the receiver object is not so if this dot price is less than other dot price, let's say, then we're gonna return -1, a negative number. So I'm gonna put here -1, and what this basically logic is gonna do is gonna swap them. So it's gonna swap the elements based on this logic. Else we're gonna return 0, and that is gonna mean that they are equal. So we type here return 0, and if you click here, it says that you can write this in a different way. So if you click on this, and let's add a print line to see that our ifs are called. So if I type here print line, I'm gonna say in if statement $, actually let's type swapping $, this dot brand name with $, other dot brand. So let's add this print line also in our else if, and I'm not gonna add it inside the else because our we don't have elements which are equal, but you can add that if you want. Now if I type laptops dot sorted, now I have a suggestion, and if I type for each print line it, so print the element. Now if you run this, look, you're gonna see the elements sorted in ascending order by their price. So you see that we have first the brand name Dell, and we have price $600. Then we have price we have laptop Acer, and we have $800. Then we have laptop Apple, the brand, and we have the price $1,000. So now they are sorted using our own logic, which was defined inside this comparable interface, and which was defined inside the which was defined by this comparable interface, and which was defined inside this function compared to that we've overridden inside our class. And as you can see, if you look, you see here that it says if in if statement swapping Acer with Dell. So yeah, the elements are swapped based on our logic. In if statements it says swapping Apple with Acer, so they are swapped based on our logic. So this is how you can use the comparable interface. But what if I want now to compare by the, let's say, RAM? What can I do? I can't implement the comparable interface again here, and I can't I can add that property here, but that is gonna conflict with my logic for the price. So what can we do? And here comes into action comparator. With comparator, you can compare your list. You can order, actually I should say, you can sort your list using multiple properties. So you can order it by the brand name, you can order by the year, you can order by the RAM, you can order by the price. And with the comparable interface, you can do that just only by one property, and that is pretty inflexible, and is not what we want. And how to use this comparator? To use the comparator, we just type here class, we're gonna call it comparator, let's say RAM, and is gonna extend from comparator. So type comparator and you have the type, and for the type here we want to compare laptop, so you type laptop here, angle brackets, curly braces, and press enter. And now we need to override the compare function inside our class. So you override that function, and here again let's change those to laptop 1. So now we have laptop 1 and laptop 2, and we define the same logic. So we type here return if, because we need to return an integer, if this dot RAM, actually not this dot RAM, laptop 1 dot RAM is greater than laptop 2 dot RAM, and we need to delete these nullables because we need to have some errors there, and put curly braces, return 1, else if laptop 1 dot RAM is less than laptop 2 dot RAM. Then we're gonna return, gonna put curly braces, we're gonna type return -1. else we're gonna return 0. Now if I want to now to compare our let's add a space here. Now I want to sort our elements based on the RAM. I'm gonna add a print line here to add a space. So I'm gonna have the back/n, also here one. So copy this, paste it here. Should be print. And now what we can do is we type laptops dot, and we type here sorted with, and we choose this one which has the parameter define a comparator, and we're gonna pass our comparator that we define here with the compare to function. So I'm gonna type sorted with, and we type comparator RAM, our class, and create an instance, and then we type dot for each, not this one, for each print line it. So now if you run this, you're gonna see them sorted by their RAM. So if you run this, as you can see, if you look at the first, they are first sorted by their price. So you have $600, $800, $1,000, and then we have them sorted by their RAM. So we have first the 4, which is the Dell, and then we have the Acer, which is 8 gigabytes RAM, and we have the Apple, which is 16. And if you look, actually they are in this order in the list. So let's change this to let's say to 16, and this to 8 to make it more clear. So let's run this again. So as you can see, they are still sorted. So we have first the Dell, which has 4 gigabytes of RAM, then we have the Apple, which is 8, then we have the Acer, which is 16. So this is why. So now it's sorting our list, this sorted with, using comparator RAM that we defined, we created, and then we loop through all our elements, because that returns a list. So this is how we can use comparator. And if you want to sort, let's say now the list by the year, you just create another comparator. So you type class comparator, let's say year, and it's also going to extend comparator is going to have for the type laptops, because it's going to source laptops, curly braces, we implement the function compare, and we define the logic for comparing elements using the year. So let's delete these nullables. Let's type here laptop 1, and here laptop 2, and I'm gonna copy this code. I'm gonna paste it here, but I'm gonna change this from RAM to year. So year, also year, again, and we have an error here missing. So let's add a curly brace here. All right. So now if I want to have the elements sorted by the year, we just type here, let's put a space also, print line, quotation marks, for session, and if I want the laptops to be sorted by the year, I just type laptops dot sorted with, and this expects a comparator. So I'm gonna call our comparator that we created, comparator year, an instance of that, then for each, not this one again, for each print line it. So if you run this, now we're gonna see the last element sorted by their year, and have, as you can see, we have them sorted by their RAM. So this is from this one, and now it's using comparator year. So it's sorting them by the years. So we have 2020, 2021, and 2022. So this is not like the order that they are defined in the list. So this is how you can use comparable and comparator. But if you think about, there is a lot of code here to just have our list sorted. You have to, if you want to, you can use the comparable, and with the comparable you can use it with just one property. And if you want to use it with another property, you have to create those comparators, which gives you some flexibility, but still we have a lot of code. And we can remove all of this code and use lambda functions. So I can delete all of this comparable that we have here. And instead of using those comparators and all of this stuff, what I can do is I can delete all of this. I can delete all this also. Now what I can do is I can add here laptops dot sorted with, and here, so we choose this one, sorted with, which has this parameter comparator, press enter, and here we type compare by, and here we type and this line of code that we have here, what it actually is doing is creating a comparator, but it's creating a comparator using a lambda expression. So here you can type it dot let's say price, right? And then for each print line it. So this is equivalent to creating that comparator here and inheriting from the comparator interface and defining the logic for ordering, for sorting them. So now if you run this will have the same effect like the comparator price that we have implemented previously. As you can see, they are ordered now by the price, and I can do now another line of code. So dot laptops dot sorted with, and we type here compare by, we type it dot let's say RAM dot for each print line and it. Now if you run this, you're gonna have the same output. Let's add a space between them, print line. So let's add a space to see the code more clearly. And now, as you can see, first they are sorted by their price, and then they are sorted by their RAM memory. So this code is equivalent to creating what we had previously with the comparator and implementing that interface and the function. And actually, there is a shorter way even to do this. We can delete this, let's say, so this sorted with and compare by, and we can just type here sort by. So this will create internally the same thing that we had previously. So if I type it dot ram, and I can do the same thing here, I can delete all of this, and I just could type here laptop dot sort by it dot price. Now this will have the same effect like all the code that we had previously, but now it's extremely concise and easier to read. You could just say laptops sorted them by their price, sort the laptops by their RAM. So if you run this code, you'll see the exact output in the console, because what this function is doing, actually we should loop through them. So let's add the print line here, print line it. So let's put here for each print line it. So now if you run this, you'll see the exact same output with just this simple line of code. So as you can see, you have the same output. You have them sorted by their price first, and then they are sorted by their RAM memory. And if you hold control on this sorted by function, as you can see, this actually internally calls the sorted with, which receives the comparator, and it's calling the compare by. So this is like a syntactical sugar for us, which makes the code more concise. But internally, it's using that sorted with. And if you want to use the sorted with, one advance for using sorted with, let's say that I type here another print line to add a space. Let's put /n, should be in quotation marks, /n. One good thing about the sorted with, so let's type laptops dot sorted with, and here we type compare by, let's say it dot year. One thing that you can do with the sorted with, if you call it specifically sorted with function, you can put dot and then by, so it will sort by year and then by I don't know, let's say it dot price. So this is what we can do with sorted with. You can sort it by year first and then by the price. So if you run this, as you can see, they are sorted first by the year, so, and then by their price. So this is why we get this in the output. Now I'm gonna end this video, and you should use this one always, because it's concise, more readable, very easy to read and to type. It's in contrast with what we had previously with creating that comparators and implementing the comparator interface or the comparable. This is a lot more concise and easier to read. So this is our discussion about the comparable and comparator interface. So this line of code, I repeat, this line of code that we have here, this sorted by it.ram, is creating internally that comparator that we talked about. Now we're just using this lambda function. So I'm gonna end the video now and see you in the next video. So there is one mistake that I did previously. So if I press Ctrl Z to have this code, when I run this code, you didn't show on the output the list sorted by the year and then by the price, and that is because I forgot to add a for each to loop through our elements. So if I add a for each, and now if I run this, now we're gonna see them sorted first by the year and then by the price, because previously it wasn't. So this is why it wasn't. Now if you look, they are sorted by the year. So we have 2020, 2021, and 2020, and then by their price. So this is why previously you saw this output, and also I saw this output, but some way I didn't saw that I forgot to add the for each here. So this is how you can use sorted with. You can sort it by more elements. You can put here, I think, another then by, not here. Here we can put another, so dot then by. You can put another then by here if you want. So it dot let's say ram. So you can add more then by if you want. So now I'm gonna end the video. See you in the next video. Now it's time to start a discussion about binary search. But before we look at binary search, we're gonna first look at linear search to see why binary search works better. So I'm gonna type a function here. I'm gonna type private fun. It's gonna be called search element, and here we're gonna type search element. So this parameter is gonna be the element that we are searching for. And then another parameter is gonna be a list of numbers. So it's gonna be a mutable list of ints, and it's gonna return a number, the search element, or -1 if you don't find the search element. And here we're gonna loop through our list. So I'm gonna type for number in our list of numbers. If at a particular iteration our number it's equal to the search element, that means that we found the element, that we found the number. So we're gonna return number. Else, if you come down here and after we loop and we did our if checks, we didn't return the number, that means we didn't find a number. We're gonna return -1 here. Now I'm gonna add a print line here, and I'm gonna type search element, because this is gonna return an element, and then I'm gonna output with the print line dot in the console. And I'm gonna type here 27, and for the next parameter I'm gonna define a list of numbers. So I'm gonna type multiple list of, and here I'm gonna define a number from 1 to 30. So I'm gonna type here the numbers 1, and our last element 30. Now, if you run this code, you're gonna see in the output 27. So we get, as expected, 27. But let's declare a variable here, I, to number the number of iteration it took to find the element. So I'm gonna assign 0 to it. I'm gonna increment it every time we loop. So I'm gonna type val, I'm gonna type I, sorry, plus plus, and I'm gonna add a print line here, and it's gonna say search number colon $I. So now if you run this, you're gonna see how many iteration it took to find our element. And if you look at the console, as you can see, it took 27 iteration before we found our element, because the way the linear search is working is it's going through all of the elements, it's checking out each iteration if the number at that particular iteration is equal to the search element. If not, it's gonna loop again and again and again until it reaches 27. Then it finds that element and it returns the element, and you get that element outputted here in the console. So this is what we call a linear search, and this is not particularly good, because imagine if you have 1 billion elements or 10 billion elements and you need to find, I don't know, maybe the 7th billion element in that array. That is going to be very hard, and it's going to take time and memory. And because of that, we have another data structure for searching elements, and that is called binary search. And I'm going to type the code for binary search here, and also you're going to see the number of iteration it took to find the element, and also I'm going to explain how binary search works. So I'm going to delete this. I'm going to type here var low, I'm going to put equals to 0, var high equals to numbers dot size -1. I'm going to explain the code immediately. Here I'm going to type while low is less than equal to high. Here I'm going to type val mid. So now I'm going to get the middle element. So I'm going to put parentheses low plus high divided by 2, and that's going to give us the middle element 15. Then I'm going to type val comparison. So I'm going to type cmp equals to numbers that get the middle element compared to, I'm going to compare the middle element with the search element. Then I'm going to type here if now I'm going to type if comparison is less than 0, then I'm going to type here low equals to mid plus 1. Else if comparison is not less than 0, so it's greater than 0, I'm going to type here that low is equal to high, sorry, is equal to mid minus 1. Else I'm going to type here return numbers that get mid, and that is going to give us the middle element. Now if I declare here a variable var I, and if I assign 0 to it, and if I increment that I at each iteration, and if I add a print line here, searched number $i. Now if you run this, you're gonna see actually I should return -1 here, because if at the end of our looping and after we checked our all of our list and we didn't find a number, then we return -1, meaning that we didn't find the element. So now if you run this again, we get search number 1, 2, 3, and then we get 27. And as you can see, this is significantly different from our linear search, because now we only took 3 searched and then he found our element. Previously we had to search through all of our elements, through our elements until the number 27 to get the number 7. But now we only get 3 iteration and we get the number 27. And how is that possible? This is because now we're using what is called the binary search. And how this binary search works, I'm going to explain it now. So now let's see how the code works. So first we have a variable declared called low, to which assign a value of 0. Then we have another variable called high, to which assign numbers the size -1. So we assign the size of the array to our high. Then we have a variable called I, to which we assign 0. Then we have a while loop and we start looping by this condition, while low is less than or equal to high. Then we increment our I to keep track of how many iterations it takes before we find our element, and we output in the console search element and the number at that iteration. Then we have a variable called mid, and this is gonna give us the middle element. And to get the middle element, we add the lowest element plus the highest element. So we add here 0 plus 30 divided by 2, which is 15. So this is the middle element. Then we declare another variable called comparison, and we type here numbers that get the middle element, which is 15, compared to search element. And if the middle element is less than the search element, that means that the search element is on the right of the numbers which come after the 15. And because of that, this is gonna return, because our middle element is less than the search element, is gonna return a negative number. So this is gonna be true. Comparison is gonna be less than 0. And then we're gonna assign low equals to mid plus on. So now the low variable has the value 16. All right. Now it will loop again. It will have the I increment, and it will do the while loop. It will increment the I again, and it will output I in the console. Now here, it will calculate again the middle element, and it will add now 16 plus 30 divided by 2, and that is gonna give us 23. All right. Now that is the middle element now. And what we do now here is we again have our variable comparison, and we get numbers that get 23. So we get the 23 element, and we compare with our search element, which is 27. And again, because our middle element is less than the search element, this is gonna return a negative number. So this if check is gonna be true again. Now what is gonna happen is that now low is gonna be equal to mid plus 1, and low previously was equal to 23. So now we're gonna have 23 plus 1, which is 24. All right. Now this will loop again. So as you can see, this basically breaks the list in half at each iteration. And now this will loop again, it will increment the I, it will output the I, and now it will calculate again the middle element. Now the middle element is 24, and the high element is 30. And we have 24 plus 30 divided by 2, and that is 27, the exact number that we are searching for. So this is how binary search works. It will compare the middle element with the search element. If the middle element is less than the search element, that means that your element is on the right side of the elements which come after the middle element. So all the elements from the left are going to be excluded, and it's going to search only on the right side. Then it will split the list again in half. If the middle element again is less than the search element, it will go to the right again. It will split the list in half, and it sooner or later it will find the element to the right or to the left. So this is how binary search works, and it's very powerful because for a very big list you can use binary search, and it's more effective than the linear search. And this is the code that I typed, but you don't need to use this code because I only type this code to show you how the binary search works. But usually you'll use the binary search function provided by the collection. So you'll just type here return numbers. We're gonna put square brackets, and I'm gonna type binary. I'm gonna type here numbers again, binary.binary search, because the binary search function provided by the collection only returns the index. So if I search for the 27 element, that is gonna return the index 26, and the index 26 then is gonna be the number 27 from our numbers list. So now if you run this, you'll see 27 outputted in the console. So we get 27, and we did this only with one line of code. You can even remove this and just have a single expression function. So we can put here equals. So just by that, it will do the same thing that we did previously with all the code that I typed. So this is our discussion about binary search, and see you in the next video. But before I end the video, I should say that binary search only works with the order collection of elements. So your elements need to be sorted in order for the binary search to work. And in our case, we used integer numbers, and it was easy because we typed our elements in a sorted order. But if the elements are not sorted, binary search is not gonna work. Also, if you have your own class, so you have your own objects, and you search using binary search through a list for a specific element, in that case your class has to implement the comparable interface, or it has to use the comparator interface, and I'm gonna show you how to do that in the next video. So see you in the next video. So now it's time to start a discussion about generics. So what are generics? Generics allows us to give to the compiler some hints about what kind of objects we are dealing with. And this helps the compiler to figure out some errors at compile time, and it also helps us to write more consistent and better code. And we already use generics when we look at collections. So every time you use an array and you specify in the angle brackets an int or a double or a class that you created, an object, what you actually did there is that you use generic. You said to the compiler that is the kind of data that specific collection is gonna store. So if you have something like this, val, let's say numbers, and we put equals here, and type array of, here you can put angle brackets, and you can specify a type here, let's say int, because I'm gonna put numbers here. And now this helps the compiler to figure out if let's say we want to add here, let's say a string. So if I type here numbers equals, let's say some text, let's put in quotation marks, some text, as you can see you have those underlines in red, which says, if you hover over here, first it says that val cannot be reassigned. So let's change it to var to get the error that I want. So let's put var here. So we get here type mismatch, required int found string. So here we are using a generic type, and the generic type is an integer, And because we said explicitly here that this array is only going to store integers, we cannot go down here and assign some string. But as I said at the beginning, generics are only a compile time feature. They don't make it through the runtime. And again, we're going to come back to this later because this has some implications. Now, let's delete this and let's create our own generic class to see how it works. Because here we're passing int, but if you click on this array of, you see that you don't have here an int. An int is the type that we specifically decided to pass to this array. But if you look here inside this library.kt, and if you go to array here, you see that we have var arg elements and we have this t. And t is a generic type, and the specific type that is going to be passed here is the type that we pass when we create an array, when we want to store some numbers or some strings. And now let's see how we can create a similar thing that we have here with our own code. So I'm gonna delete this. So again, generics are there to help the compiler to figure out errors, and it also they are there for helping us to write better and consistent code, so that you don't add let's say strings to an array which is meant to store only numbers. So first I'm going to create a class, and it's going to be an open class, and it's going to be called player, and it's going to have a property called name. So it's going to be a val name. We're going to define this in the primary constructor, and it's going to be a string. Now I'm going to create open class here, and down here I'm going to create two classes. First is going to be called football player, so football player, and this is going to have a name, and it's going to be a property because we're going to extend from our player class. We're going to derive from our player class and going to pass that property to that parameter name to our property name from the superclass. So we type here player because we are inheriting from it, and here we pass name. So we pass here name. Next I'm going to create another class called baseball player. So we type here baseball player, and this is also going to have a name, also only a parameter because the property is going to be ultimately defined by the superclass, by the class from which we are inheriting from. So here we're going to inherit, put a colon to inherit from our player class, and here we pass our name parameter that we defined here. We pass it here to the primary constructor of the base class from which we are inheriting from. Alright, so now I'm gonna go up here, and now I'm gonna create a class called team, and this class is gonna represent a team, and this team can be a football team or a baseball team. And here we're gonna create a class called team, so we type the keyword class. I'm gonna call it team, and now here we put angle brackets, and inside the angle brackets we're gonna define the generic type t. And you can use a different letter here if you want, but usually and generally use the T because it stands for type parameter. Next we put parentheses to define the primary constructor, and for the primary constructor I'm going to define a val name, and this is going to represent the name of the team, and it's going to be a string. And next I'm going to define also a val, but this is going to be called players, and it's going to be a mutable list of also of type T. So we type here mutable list, and we put here T. Right? Now I'm gonna put curly braces because I'm gonna define a function inside our class team. So here we type fun, and I'm gonna call this function add players. So this function is gonna add players to the team. We put parentheses, and here we define a parameter called player, and it's going to be of type T. So it's going to be, should put a colon here, and we put curly braces. and this is going to receive a parameter of type t, and this type t that we define here and here and here is going to be the type, a specific type that we going to pass when we create an instance with our class team. So first here we're going to check if the players, so our list of players contains this player that is passed to our add player function, because if we already have that player in our list, we're not gonna add it to our list. So if player, and to check if that player is in the list, we call the contains function on our mutable list. So here we type players dot contains player, the argument, and if that is true, we're gonna put curly braces, and here we're gonna output something that goes to the console. So we type here print line, quotation marks, and we type player, colon, and then we put $, curly braces, and here we need to do something which is called casting. And casting is used when you want a variable to be treated as a certain type of variable. So when you want a variable to be treated by the compiler as a certain type of object or a class. So we type here player, because let me show you why we need to do that. Because if I type here player, now I want to get the name, and if I put here dot name, as you can see, we don't have any name here, because this t and this t that we have here is generic. The compiler has no idea if this t that is gonna be passed here, so if you pass here a baseball player or football player, it has no idea if at this moment now if that is gonna have a name property on it. This is why when you type here dot name, we don't get nothing. And to solve that, we can say to the compiler to treat this parameter here, so this is gonna be a value passed to this parameter, as a player. And in that sense, in that way, we can get access to the name property. So we type here player, and to cast a variable to a certain type, we put as. So we put the keyword as, and we type player, and we put this in parentheses. So we surround our expression in parentheses inside the curly braces. And now here at the end of the enclosing parenthesis, you put dot, and now we have access to name, because we said to the compiler, hey, treat this player variable. I don't know, because I don't know if this is gonna be a player object passed here, or a baseball player or a football player. Treat this player variable that is passed here as, because here we have t, so we don't know what it is. Treat this player variable as a player, so you can use the name of a variable. And we're gonna say is already in the team, and we can put here the team, and we can type here $, this dot name, so the name of the team. Else, if our player is not in the team, we put else. We're gonna press enter to add the right curly brace. We're gonna add this player to the list, because if the if fails, that means that the player is not present in our list. So we type here players, our mutable list, dot add this player that is passed, player, and we're also gonna output something to go to the console. So you add here print line, and I'm gonna copy this because I'm just gonna change the text a little bit. So let's delete this player, and so here we're gonna say, instead of it's already, we're gonna say was added in the team. Now let's create some objects with those classes that we have here. So first I'm gonna create some players. So I'm gonna create first a football player. So type here val football player equals football player, and for the name I'm gonna use a generic name. I'm gonna type just football player 1, and I'm gonna press Ctrl D to create another football player. So football player 2 is gonna be called, and I'm gonna create two baseball players. So we type here val baseball player equals baseball player, and we type here baseball player 1, and I'm gonna press Ctrl D here also. I'm gonna call this baseball player 2, and I'm gonna change this to 2. Now I'm gonna create an instance of our team class. So we type here val team, and this is gonna be a team of football players. So we type val team equals, and here we type team, and we put now, because as you can see it's expecting a type here, and the type is gonna be a football player. So it's gonna be a team with football players. And here we're gonna define a name, also a generic name, football team is gonna be called. And we also need to pass an array there. And for this array, we're gonna type just mutable array of, but I can't. List of, and here I'm gonna pass our football player. I'm gonna pass only our first football player here. Now I'm gonna create another team, val team. Let's actually call this first team football team. So let's type here football team. Now if you run this code, we don't get any output because our add players function wasn't called. But if I type here football team, actually here football team dot add players, and I'm gonna add football player 2. Now if I run this code, we get football player 2 was actually here should be added. Football player 2 was added in the team football team. So our code works well, and we use generic types for our classes. Here we specified only the T, and this T that we have here was replaced with football player that we define here. And we're gonna do the same thing. We're gonna create another team for the baseball player, and we're also gonna look at how we can restrict the types that are gonna be passed to our generic type here. So now I'm gonna create a baseball team. So I'm gonna type here val baseball team, put equals, then you put here team, and here we type for the generic type T baseball player, because this is gonna store baseball players. And we define a name here. The name is gonna be baseball team, a generic name. And also here we need to type to pass a mutable list, so we type mutable list, and we pass here a baseball player. But as you can see here, for the type, the type here is grayed out. That is because here we pass the football player object that we created, and here we pass the baseball player. Because Kotlin has type inference, it can infer the type as being a team of football players. So you don't need to put here football player. You can delete this, you can delete all of this, and now our code still works. And you can see we have this type hint which says team football player. So it's a team of football players, and it's inferred automatically by Kotlin for us. And you can do the same thing here for a baseball player. So I'm gonna delete this, and as you can see, now we also have the hint team baseball player. Now let's add to the baseball player. Let's call the baseball player function. Let's put here so we type here baseball team. Let's call the function that add players, and here we type baseball player 2 because first one was added there. So now if you run this code, not debug, so run this code, let's increase this, we get, let's actually decrease this, so let's put here, we get player football player 2 was added to the team football team. So we have this code here which is called, and it says that the football player was added to the team and the name of the football team. And then we have player, and we have baseball player 2. So this one that we have here, that we pass here, baseball team, that was this to the baseball team. As you can see, it says player baseball player 2 was added to the baseball team. And what generics helps us to do, because as I said, they can help the compiler to figure out errors. If you try to pass here baseball team dot add football player, so we type here football player, now you get an error because the generic type enforces the type on the class, because here we said explicitly that this is because this was inferred to be as a baseball player. We cannot pass here a football player in our baseball team because this is enforced, because we said here explicitly because this was inferred from here. So we have team baseball player, so we cannot add here a football player inside our team football player, and this is very, very powerful for us because in this way we don't do things which doesn't make sense. And the same is true about our football team. So if in our football team, we type football team dot add, and here we put baseball player, we get an error because we specified that because the generic type was inferred to be a football player, so we cannot put a baseball player in our team of football players. So this is what generics is doing, is figure out those errors for us at compile time, and this is very powerful because we can run our code and we don't get in those some scenarios where we have a baseball player added to a baseball team, or maybe other examples there. So I'm gonna delete this. Next we're gonna look at upper bounds, because upper bounds basically allows us to restrict what kind of type is passed to our generic type here. So and particularly gonna see how this is gonna affect this code that we use here to cast. So to add an upper bound, so to restrict what kind of type is passed to this type, we can put colon, so extends, and here we can type player. So what we're saying here is that every type that is gonna be passed here when you create an instance, like we did here. So, but only that this was infer here. This type that is gonna be passed here needs to inherit from the player class. Otherwise, this type is not gonna work. So, because of that, because the compiler now knows that and enforces this, that this type that is gonna be passed here is gonna inherit from the player class, we can't delete this cast, because now it knows that that type is gonna have is gonna inherit from the player class, so it's gonna have the property name. So if I delete this, and if I delete this, so let's put name here. Now, so let's delete this too. Should be player here. Player. So now we have player.name, because it knows that this type, so this type that is gonna be passed here is gonna inherit from the player class, so it's gonna have the property name. So you don't need to do this weird casting. So I'm gonna delete this, and now as you can see we don't have any errors. So now we have the name here, because now it knows that whatever type you pass here, it has to inherit from the player class. So if I go down here and I create another class called gamer player, so we type here class, let's call it games player, and it's gonna have a val, it's gonna be, actually let's define a parameter only, name is gonna be a string, and we will not inherit from our player class. Let's see what happens. So if I create here another team, let's call it val, let's call it the games team. So I'm gonna type here team, and we're gonna specify here games player. Now if I put now the primary constructor here we need to define a name. Let's call it games team, and a mutable list of. Now here we have an error, and if you look, it says expected player found games player, and this happens because our games player that we have here is not inheriting from the player class, and because we said here that the upper bound is this t that is passed here, so this t is this here, has to inherit from the player class. Otherwise, if you don't inherit from the player class, it will not work, because we said here that it must inherit from the player class. Now if I change this down here to inherit from the player class, so we type here player, we type here name. Now as you can see, the error disappears, because now it's respecting the upper bound that we set up here, which is t, meaning games player has to inherit from the player class, and then down here it's inheriting. So this is our discussion about how we can use generics, and how we can define upper bounds. And in the next videos we're gonna look at type erasures, and you're gonna look also at reified keyword, and how we can inline our function with because you need to inline your function when you use reified keyword. So see you in the next video. Actually, before I end the video, I should say why this generics is important. Why? Because if you think about, because here we can type, we can define a generic type. We don't need to create a separate class for every team that that we want to use. So we don't need to create a football team, we don't need to create a separate baseball team, we don't need to create a separate games team. We just create a team, we define the generic type T, and here we pass our our type, and in this way we can use only one class, and we can have all of those baseball team, we can have the football team, we can have, just by having the type here, which is generic. Otherwise we'll have to create separate classes for each of those teams. So see you in the next video, and next video, as I said, we're gonna look at type erasures and reified keyword and the inline functions. And in the next videos we're gonna look also at covariance and countervariance. So see you in the next video.